Here's a fun little video about connecting up a microcontroller like, so this guy is a Trinket Focus 2, or maybe it's a Trinket Pro, or maybe it's a standard Arduino. You can do this with those as well. We want to hook it up to a servo. So on the servo connector here, you got your 3 pins. You basically got power, the red wire in the middle there, and then you got the orange signal, and this, in this case, brown. That's ground on the outside. So this is 3-pin connector, and you want to hook up maybe 2 of these or 3 of these or something like that. So over here you got some signal pins. You got 0, 1, 2, but there's just the 1 pin, and then what are you going to do? You got to take the connector apart, and you got to hook the ground all to the ground over here. There's only 1 ground pin, so how are you going to do that? And you got to hook up your battery. So the idea that I had initially was just to take this and a little angle. Let me show you that real quick. It's just a right angle header. These are like commonly available all over the place. And if you put it in there, well, now you got your signals. You can at least get out a couple of them. Of course, I could put it over here as well. Same basic deal. So I could have my signals coming out, and I could hook up. Like I could take this row of pins here, and I could put those all on a ground or something. But that's what I want. That's not what I want. I could put that all in power, but then I'd be missing 1 row of pins here, which would need to be for, let's see, if this is going to be power and that's going to be signal, so that has to be ground, right? So I don't have anything for the ground. So I came up with an idea of combining a straight one and an angled one. The way we're going to do that, it's a little bit tricky here. What we're going to do is just take a pair of pliers and push this pin out. You see how it's hitting the other one? So now what we're going to do is just take it and kind of twist it like that. So this one is just kind of being bent ever so slightly out of the way. Not bent permanently, just bent a little bit, so that we can push that right there and work it back and forth until it comes out, right? So we've removed that pin. I'm going to go ahead and do the same thing on this one. Just up to the point where it hits. Do a little twist. Push it the rest of the way. Work it out. One more. Okay, I probably bent that one. I went a little too far. It's alright, you can bend them back. Work this out here. Okay. So I will just clean that up a little bit. Okay, so now what we're going to do is we're going to take this one and we're going to put it through, let's see. Is that right? In this particular case, I'm not going to use those last 2 pins. So I'm actually going to break this one down. Take off 1 thing on it. So it's just 3. So you would do however many you need, right? So now what we're going to do is go ahead and push this into the holes on this one. Not sure if you can see that, but I'm just going to get it started. Kind of push it down in there. There we go. That's not too bad. So you got that done. Now, of course, the issue here is it doesn't line up, right? So you have very uneven pin lengths here, but that's okay, because what we're going to do now is we're going to go ahead and solder a wire across the we're going to solder a wire across these pins here. Right, so I'm going to solder a wire that goes right down that set of pins, and I'm going to solder another wire that goes right inside there. And I want this space, this gap in here, so that I can get my soldering iron in there and do that soldering. That's a little bit tricky soldering job. It's a little bit of a pain in the butt to do. But then once that's done, I'm going to go ahead and push, and I'll just do this now so you can see what I mean. I'm going to push these all the way down. And these, you know, might not even be here. They're not important. And now I've got this great big huge gap, and what I'm going to do is I'm just going to push these down until there's just clearance right there. See? Alright, so we've got that little bit of a gap. So when I put this in here, you know, it won't short necessarily. And I see that I've done this backwards, but that's okay. This is just a demo. So the point here is that I'll have signal, 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 and then I'll have +5 on that middle row with a wire that will hook out to either the USB or the battery pin. So I'll just, you know, bring a wire out and plug it into that. And then this this outer set right here will be ground. And then what I'll do is I'll just cut off these pins at this length right here. These particular headers are a little bit longer than normal, so I've got a little bit of room to work with there. And I would go down and do the rest of them. And now this connector will plug very nicely on there. And if I turn it around the way it's going to be, let me pop it out of the package real quick. You can see that it will have signal up here going into the pin on the processor. It'll have power on that center row, and it'll have ground on this bottom row. And that'll be a little bit stronger once all of those are soldered down. I managed to actually shove this pin back, trying to put that on there. The other thing is, when you're clipping these, you have to make sure that you don't have any burrs or whatever left, because otherwise it's really hard to get it into the actual connector here, to get it lined up right, and to make it to go on. There we go, that's a little bit better. Okay, so does that make sense? Yeah. For a better example of that hack, here's a little MeArm robot arm. This is built from actual open source files, hooked up to an Uno, and in this case, let me see if I can turn this so you can see it a little bit better. It's more or less the same idea, but just with the connectors plugged into the header. So again, there's wires soldered on in there, and then pushed down right to the edge of the connector. And in this case, I used actual wire, because those needed to be plugged in over here on the ground and VN, or they could be connected directly to the battery pack or whatever. But just a hack way of getting your servos connected directly without a servo PCB. So a little bit of fiddly soldering later, and there's a finished result. Soldered in on that bottom row, and then the middle row has the power going to it from that BAT plus connection. You can see ground wire. That silver wire going down there then goes to the ground pin here. There we go. The battery connector is going right down the middle. Let me turn it so you can see that. It's this pin closest to us here, this pin on the top, and then there's a little bit of an angle, and it goes right down the middle. And again, that was all soldered before I slid this black piece closer to the pins. Or to put it another way, before I slid these angled pins down. So anyway, now we have a set of 3 places where we can plug in servos there that have, you know, the battery power in the center, the signal coming up from the bottom, and ground on the top. And they're just clipped off to all be more or less the same, and then I briefly filed the leads so that it could be connected on there. Okay, so that's just a crazy little hack to get servos connected in a very small space to whatever little microcontroller board you're using.